Now we're going to talk about discrete probability distributions and random variables. So let's start off with some definitions. First of all, a random variable is a variable that has a single numerical value for each outcome of a procedure. In plain English, that means a random variable comes from a random process. Think flipping a coin or rolling a dice, or randomly selecting a student. And all the outcomes of that process are numbers. So maybe when you roll the dice, the value that you get when you roll the dice. If you randomly select a student, their grade, percentage, I guess, in that class. Secondly, a probability distribution describes the probability that each value of the random variable will occur. So let's take a look at some examples. Let's actually talk about probability distributions really quickly first. I forgot there are two requirements we want to worry about for a probability distribution: that the sum of all of the probabilities listed in the probability distribution must sum to 1. Secondly, all those probabilities that are listed must be between 0 and 1 for any of our random variables x. Now let's look at an example. The following table here, does this following table represent a probability distribution? Well, on the left, we have our random variable values x. So x could be 0 or 1 or 2 or 3 or 4. Think of like maybe a 5-sided dice where we could show the dice side is 4 or the dice side is 3 or 2 or 1 or even a dice side that's 0. And the probabilities of each of these happening are given on the right side. Now, these look like great probabilities. They're all between 0 and 1, like they should be. But when we add up all of the probabilities listed, we only get 0.91. And since that's not exactly 1, this is not a probability distribution. We can find the mean, the standard deviation, and the variance of these probability distributions. So the first formula we're going to use is finding the mean of a probability distribution. And we find that by adding up all of the random variables multiplied by their own probabilities. So I'm going to do an example in a second, but I'd like to get the other formulas up first for you to write down. Secondly, again, we have two possible formulas for a standard deviation. The first one is taking the square root of the sum of each random variable subtracted with the mean, that quantity squared, and then multiplied by that random variable's own probability. And then the second one is sometimes a little bit easier for calculation. It's the square root of the sum of each random variable that's squared, multiplied by his own probability, and then subtracted the square of the mean. Then finally, the variance is great. The variance is just the standard deviation without the square root around it. So let's do an example. Let's find the mean and the standard deviation of the following probability distribution. Now, before we jump into doing this, I want to point out really quickly, our random variable is x. X could possibly have values, numerical values, 0, 1, or 2. And the probabilities for each possible value of x are given on the right. And secondly, I want to point out that each of those probabilities is between 0 and 1. And lastly, I want to point out that if you add up 0.64, 0.32 plus 0.04, you will get exactly 1. So this is a probability distribution. Okay, let's go back. Let's find the mean. So when we find the mean, we're going to take each random variable and multiply it by its own probability and then add those all up. So 0 times 0.64 plus x value 1 times its probability 0.32. And then finally plus 2 times its probability 0.04, and we get a mean of 0.4. To find the standard deviation, we're going to take the square root of each of those x values squared times its own probability. And then we're going to add those all up and finally subtract off the mean squared. So when we do that, we're going to have to take the square root of 0.32, which gives us 0.5667. Okay, one last set of formulas that we'll need to know to help us figure out what we would consider usual or unusual values. So the range rule of thumb tells us that a usual value would be 2 standard deviations away from a mean. So the maximum usual value would be the mean plus 2 sigma, and the minimum usual value would be the mean minus 2 sigma. So let's do one last example where we look at that. Let's find the mean, the standard deviation of the following probability distribution, and then we'll use the range rule of thumb to find the maximum and minimum usual values. So this one's quite larger than the last one. There are other programs you can use to find the mean and the standard deviation. I'll make most of the problems pretty short. So we're going to calculate the mean by, again, taking each x value and multiplying by its own probability. And then we're going to find the standard deviation using the formula we did a minute ago. So when I did that, I got the mean is 4.05 and the standard deviation is 1.89. You should double check using the previous formulas to make sure you can come up with the same numbers. For this problem, I really want to discuss the range rule of thumb to find the maximum and minimum usual values. So, to find first the maximum usual value, we'll start at the mean and we'll add 2 standard deviations. So 4.05 plus 2 times 1.89. So the